Hello everyone, and once again, hello and welcome to another session of your FEAL. Now, last time we had finished the simply supported beam with a combined load. Now we are doing a plate with a central hole. Okay, a plane stress analysis on a plate with a central hole. Now, for this particular problem, they are given a rectangular plate of 200 by 40 mm, which has a thickness of 2.5 mm. Okay, sorry, the breadth of the plate is 100 mm and the diameter of the circle is 40 mm. Okay, now in this question they have given the thickness is 2.5 mm. Even if the thickness is not given, you can make it as a surface and you can solve also. Okay, that is also possible. So I will show you this way of doing it, and I'll just explain to you how to do it if thickness is not given as well. So let's head on straight to our Ansys workbench, and we'll open a new static structural. Here they haven't talked anything about the engineering data, so we'll just assume it is structural steel and not do any other process. Okay, so geometry, we need a design modeler. Okay, so it was in units, was in mm, so we'll choose mm. XY plane, look at that, and then go to sketching, settings, grid. We'll just click on the grid. We'll see how depending on our value, we'll see whether we need to do any changing. Maybe we can if we give 100, we won't be able to draw the circle properly. So we'll just not do any changes here. Okay, we'll just leave it as it is, and then we'll draw the rectangle first. So let me draw a rectangle, and let me take dimensions, and let's see how they are. Okay, so they're okay, since it was 10 mm, it came out very bad. Okay, no issues. So we need this to be 200, and we need this to be 100, I believe, right? Okay, so this is what we need. So we need this to be in the center now. So what we can do is, again we can hit horizontal from here to here. Okay, this we can give it as 100, and then I hope you understand what I'm doing here. I'm just giving these dimensions from here to, so half of the dimension, right? So if I give half of the dimension, I can easily bring my rectangle to the center. That's all I'm doing. Okay, now I have perfectly in the center. Now what I have to do is I need to draw the circle in the middle, right? So we'll go to draw circle. Okay, so if you don't know how to use any of these tools here, okay, after you click on a particular tool, just take a look at the left bottom here. Ade on this hold, like it will tell you what you have to do. So for a circle, click or press and hold for the center of the circle. So I need this to be the center, so I'll just press and leave. Okay, and now it is forming this thing. So it's supposed to be 40 mm, so I'll just draw some arbitrarily some value. Okay, and I'll go to dimensions. I'll take I have the diameter, right? They again the diameter is 40, so I'll take the diameter, click on the circle, I'll get the diameter. Okay, so what I drew is basically, oh, it came out 40. How good. Okay, so no issues there, it came out exactly 40, so we'll leave it there. Now we were given a thickness of if you remember 2.5, I believe, right? Let's check here. Yeah, 2.5 mm. Okay, now if the thickness was not given, it's pretty simple. Just go to concept, lines from sketches or surface from sketches, and you can create this sketch surface very easily. Okay, just click on that, click on the sketch, and then hit apply, hit generate. You will get the surface. Okay, you can do the analysis on this also, there is nothing wrong. This is like a sheet metal, like it has 0 mm of thickness, right? So it is a model with a 0 mm thickness, but still you can do analysis on it. So right now they have given thickness for us, so because of that we will not use the surface method. Okay, so what we will do is we will, as usual, extrude it. Okay, yeah, it is for sketch number 1. Hit apply, Now depth we need to give, yes. So but before that, right, what we can do is we can have the center of our plate exactly on the origin. Okay, so if a depth 2.5 la, if you divide 2.5 by 2, 1.25 mm on the one side and 1.25 mm on the other side. Appdi, like you can do that. Okay, so you just need to come here, okay, and click on both symmetric, and then go to depth, and it's 2.5 divided by 2. Inge appdi pannikkalam. So okay, for some reason it didn't change. Fine, no problem. So it is 1.25 mm. Okay, so for that 1.25 mm, basically what it will do is 1.25 on one side and 1.25 on the other side. So you'll get a perfectly equal symmetric model. That's why that was the aim. And you can add material here if you want. It doesn't matter. It will anyway add later. So hit apply and you will get the model now. So what is the difference between this and the surface? This has a thickness. Okay, now since we have given this body to have some kind of thickness, it will have, see, volume, surface area ellame irukku. Okay, if it was a surface, it wouldn't have had a volume because it's a zero thickness surface, right? So since this is a extruded body with a thickness of 2.5 mm, let's rotate and see here. See, you can see it, right? So exactly in the middle I have drawn it. Okay, this is a plane cutting, and 1.25 to the one side and 1.25 the other side. Okay, if you want to see the other one also, I can show the the sketch surface ones as well. Surface from sketches, apply, and then generate. See, so this is the surface that I create. See, it's perfectly on the plane. Okay, there is no thickness at all. It's zero thickness. You can do this analysis like this as well. But in the question, since 2.5 mm of thickness is given, we are doing it all. Typically, you do a zero thickness examination only on this. Okay, you can do that as well. So we don't need this, so we will delete this. If you don't want any particular module here and like என்ன சொல்றது, delete பண்ணாம அது அங்கே இருக்கணும் அப்படினா, you can do the thing that I did for extrude. It's called suppress. Okay, now it is unsuppress, so that I can bring back this model here. Okay, so yeah, this is fine. I'll just save this. Save this project. I think it got saved in the other previous models, so let it be there. I'll close the design modeler now. Okay, now I need to open up mechanical. So as usual, do wait so that it will come. Wait for some time. For some people it might be very fast, for others it might be very slow, even slower than mine. So please look into that. Okay, so yeah, you have your model now. So what we can do is, as usual, we'll start with meshing the model. So let's just mesh it once and see how it is going to look. Okay, just generate mesh. Let's see. Okay, so we got something, but at the we are actually interested in the circular, this part of the model. Okay, how it is going to be. So I think the mesh is not so good, so let's try some different sizing maybe. So you can change your sizing here, or you can do this as well. Insert sizing, and let's see, I'll select the whole face. Okay, and element size, maybe I'll give it as 5 mm. Okay, let's hit generate mesh now. Okay, it's looking much more better. Still, it is not a perfect model. We need to still further mesh it better, but for the purpose of this demonstration, I'll just leave it like this. Okay, now since this is over, next again, if you take a look at the question, what is there? There is a pressure of 5 megapixel, sorry, not megapixel, megapascal, that is on both left and the right sides. Okay, so both on the left and the right side, they have given there is some kind of pressure. They did not tell whether it is outward or inward. Actually, they would have given that, but they have not given here, so we'll just take any one direction and do it. Okay, inward or outward abdina, what I mean is like they will give either pressure is acting in this direction like a compression force, or whether it is acting in the other this way. Okay, so this they will give. Here they have not given, or I forgot to mention. So we'll just take any one of those methods and then we'll continue. Okay, so back to here. Okay, since this is like a bit new to me, so I'm just taking a look at what are the options available here for display. Okay, fine. Okay, so anyway, we'll go back to our model itself. So meshing is over. Now to static structural, we need to apply. There are no supports and all here. There is just pressure mattum da irukku, correct? So we'll go to static structural, insert pressure. They are given pressure. Okay, that's why it doesn't matter. Like pressure and force are almost the same, so no issues. Okay, pressure, and so it will be on the sides, right, that they mentioned. So on this side and on this side. Okay, so you need to hold control and click if you want to select two faces. Okay, so hold control and click to select the two faces and then hit apply, and we need to give a value here. So it is 5 megapascal. So this is already in megapascal, so you just need to hit 5. Okay, so this is already in the inward direction now. It's in the inward direction, so we'll not do any change. Okay, let it be compressive. We'll try to analyze this. Now you can go to solution. Here you will go for total deformation, because we need to understand the deformation of the entire thing, and also we need the equivalent stress to find the maximum bending stress as well. Okay, so as usual, it's nothing big. You just need to hit solve. Okay, there might be errors here and there, just ignore that, that's okay. Okay, so some of you might have got the answer if you had tried that method. So I don't have the screen right now because I got some error and it came out. So I think there is some issue with this version for that particular model. So basically it was telling me to give some constraints to it. Okay, so better than this is a symmetrical model, right? This is symmetric about both this axis and this axis. So instead of actually solving the whole thing, you can just do 1/4 of it and then you can map it to the other three sides. It's the same thing. Okay, so you just need to do 1/4 of it, so that you can do it here. So if you go to tools, symmetry, and then plane of symmetry is asked. So one is in the ZX plane, apply, generate, and tools, symmetry again, and the other one in the YZ plane. Yeah, so apply and then generate. Okay, so this alone is enough for our analysis. So I think now it will work properly. Okay, so let's go to our mechanical now. Again, those who tried with the full model, some of you it might work. For some reason my version did not work. அவ்வளோதான், நீங்கள் ட்ரை பண்ணிங்கன்னா உங்களுக்கும் ஒர்க் ஆயிருக்கும். For some of you it might have worked. Okay, so anyway, moving on. In the model now, so we have yes, this half model that is displayed for us. So இப்போ symmetry புதுசாக இங்கே வந்திருக்கு, since you are given that. So we'll just I'll just mesh this for simple mesh பண்ணுறேன். நீங்கள் வேணால் you can make it much more better, but for our demonstration this is enough. So I meshed it. Now we need to give the pressure that was mentioned, right? So in the side la, and it's 5 megapascal. Okay, so we'll give that a compressive mari. Now again, if you hit solve now, it will work for few people again. So for me it is asking me to give constraints now. So usually for a plate, for this flat plate, you don't usually do a constraint here. You just give forces and you calculate. But for some reason Ansys is not allowing me to do it, so I'm going to add that alone. For some of you this might work. Idu mudichu nee solve ni adichalu it will work. For me it did not work. So what I will do is I will add some constraints here. So basically I'll add a displacement here on this surface. Okay, so basically it can move in the x and face path. Yeah, it can move in the x and the z, but not in the y direction, right? So y it will be 0. Okay, and also I didn't give a selection. Yeah, apply. Okay, so that is your first displacement, and next another displacement on this face. So if you take this face Abdin Patina, it can displace along y, but not in the x direction, I believe. So 0, and finally another one for the back side of this. Okay, so hit apply, and here it should move along with Z, I believe. Okay, so let's try hitting solve and see. Okay, so it did solve something. Let's see if we did it correctly. So we need a total deformation and we need the equivalent stress. Okay, yeah, so we got our required results. Okay, so there you have it. These are your answers. Yeah, and as usual you can animate them as well. So this is a representative of all the other faces as well. Okay, so you can do it in this way for both equivalent and this stresses and deformation as well. Okay, so this is how you do analysis for the plate with a central hole. Like I said, you can do it with the whole model. Some of it might work. For me it did not work, so this is much more easier to do. It takes up a less computation time. Since it's symmetric, you just need to study the characteristic of one quarter here, and you can map this to the all other 3 quarters as well. Okay, so with that, yeah, you can probe all the values, you can take as the minimum, maximum, all this you can do. So with that, we will finish this experiment and we will do another one in the next video. So thank you.